starting back on 21. It says given the following exponential function, identify if it's growth or decay. So remember, so for growth, it's if the number in parentheses is above 1, and decay is if it's between 0 and 1. So right here, we can see that this is decay. Because it's below 1, and then determine the percentage of increase or decrease. So we do 1 minus this number for decay. So to find out how the percentage of decay, we're doing 1 for 100, like 100%, and we move the decimal place twice, so we're just doing 1. 1 minus 0.04 is 0.96, which as a percent is 96%. So move the decimal place twice. So it's decay, and we have a 96% decrease. Oh, 96% decrease. Okay, and then same thing here. We can see that this is growth because it's above 1, and then determine the percentage of increase or decrease. So we're trying to see how much this is above 100%. So we're going to do 1 minus 1.058. Oh, back. I just said it and then did it backwards. Sorry about that. So 1.058 minus 1 equals 0.058. And if we move the decimal place twice, 1, 2, it's going to give us 5.8%. And this is an increase because we were above 1. So this is exponential growth, and it's 5.8, showing that 5.8% increase. Then 23. Remember, the base equation for these is y equals ab to the x, and this is your initial amount. This is my ratio, which is basically 1. My ratio, which is 1 plus my percentage. And then time is usually x, so this is my time. And then this is my ending amount. This is my ending amount, okay? So we have an element with mass 570 grams, so it starts at 570. So this is my A, it's my initial amount. Decays at 18% per minute. So as a decimal, this is 0.18. And we got to see what it is. My ratio is 1 plus or minus my percentage. It should be 1 plus or minus. So 1 plus my percentage if I'm going up, or it's 1 minus if I go down. So my rate is going to be, my ratio is going to be 1.1 minus 0.18 equals 0.82. So that means my ratio is going to be that in parentheses, and then it wants to know how much of the element is remaining after 13 minutes. So this is my x value, my time. So if I write this in, y equals 570, 0.82 to the 13th. So y equals, if I put this in a calculator. 570, 0.82 to the 13th. It's going to be to the nearest tenth of a gram. It's going to be 43.2. Okay. 24. Same exact problem with different numbers. So here, this is my A. My B is going to be a little bit harder. My B here is going to be, it's decay again, so 1 minus 0.188 equals, let me do this with my calculator, just to make sure I don't mess the math up. 0.812, so if I move the, so 0.812. I'm going to do the decimal place on this one, 0.812. Okay. Then it wants to know how much of the element remains after 7 minutes. So 7 is my x. So 630, 0.812 to the 7. So y should equal 146.6. Okay. And then we get the same kind of problem, except for this time we're going to be solving for time instead. So a new car is purchased for $18,000. So this is my A. The value of the car depreciates, so it goes down at 6.75 per year. So that as a decimal would be 0.0675. So 1 minus 0.0675. So 93.25 is my B. So B equals 1 minus 0.0675. So 0.9325. Yep. And then to the nearest tenth of a year, so we don't know X. We don't know our time. To the nearest tenth of a year, how long will it be until the value of the car is this? So when my ending value is this, so this is my y. So if I plug this into y equals AB to the x, I've got 7,100 equals 18,000, then 0.9325 to the x. Okay. So first thing, this becomes a lot like, where was it at here? This becomes a lot like 17. I divide if I need it, if needed, use base on bottom, get x by itself. Same thing here, just with weirder looking numbers. We're going to divide by 18,000 on both sides. Probably help if I zoom in a little bit. Let's divide by 18,000 on both sides. So 71 over 180, 71 over 180 equals 0.9325 to the x. So I need to get x by itself, so logs are base. This is my base, this is my exponent, and this is my answer. So logs are base, so log base 0.9325 of 71 over 180 equals x. So I'm going to rewrite this with base on bottom. This is my base. It's going to go on bottom when I type it in. So log over log for base on bottom. 71 over 180. and we're nearest to the nearest tenth of a year. So when I type this in, let me go ahead and type it in on a separate screen just so I can look at it at the same time. So let's type it in, log of 71 over 180, and log of so if I type that in, I should get 13.3 years. 13.3. So x equals approximately 13.3. Okay, same thing on 26. We have a population starts at 7,000 and it grows at 5%. So I've got 1 plus 0.05 for my b. My b equals 1.05. And then to the nearest year, so how long, we don't know x. Will it be until the ending population is 19,000? So that's my y, so 19,000. We're using y equals ab to the x. So 7,000, 1.05 x. So divide by 7,000 on both sides. And that just gives you 19 over 7 equals 1.05 to the x. Rewrite it with b, e, a. So log base 1.05 of 19 over 7 equals x. And then rewrite it with base on bottom. So log over log, base is 1.05 over 19 over 7. And notice here to the nearest year, so the nearest whole number, this should give you 20 equals x. As we move to 27, we're talking about in a lab experiment, 100 petri dish, 100 bacteria in a petri dish. The conditions are such that the bacteria doubles. That's really important every 24 hours. And then how many bacteria would there be after 14 hours to the nearest whole number? So remember, you've got a doubling formula and a halving formula. The doubling formula, I'm trying to use the same one that they use. The doubling formula is this. So y, and this is definitely an index card type of thing, y equals a times 2. And the times 2 is because I'm doubling. And then you've got t over d. So d is how long it takes to double. So the doubling time. T is the time they give you. And my A is my starting amount. Same as before. My initial amount is what we were saying before, starting or initial. I'll be consistent. Initial amount. And then this would be my, I'm ahead of myself, my ending. Amount. Okay. So let's just plug in. So this is my initial amount, A. It takes 24 hours to double. And then how many bacteria would there be after 14 hours? So T is how long I'm waiting. How many bacteria? I want to know my ending amount. I don't know it, so I don't know my Y. So Y equals 100. I'm doubling, so 2 to the 14 over 24. I just type that directly in, and I should get, let me check, and we're rounded to the nearest whole number. It should be 150. Okay, so 28, same idea. This is we're doubling again, correct? Yep, doubling, so using the doubling account, doubling formula. Started with this, they double every 12 years, so D is 12. We want to know after 6 years how much money there would be. We don't know our Y. So Y equals 140 times 2 to the 6 over 12 to the nearest dollar, whole number. So that would be 198. So this is the other one, the other formula. We're doing the halving formula because we're going up by, we're changing by half. So the halving formula, definitely an index card kind of thing. So Y equals, let me make sure this is the same format that they use on Delta Math, because if you get it on Delta Math and like you click show example, I want to make sure I'm using the same exact formula. Yep. So Y equals A 1/2, and instead of T over D, it's T over H. So this is the halving time, how long it takes to halve. This is my halving time. This is just my time I'm like passing, and then this is my initial amount. And then this is my sorry, it's the end of the day. My thoughts are running from me here. This is my ending amount. So if I plug all this in, I want to know how much. So let's go through and see. Oh. We start with every 20 years, it decreases by half. So my halving time is 20. The initial mass is that. So A is this. How much of the element would remain? So how much of the element? We don't know why, that we don't know the ending amount. And we know that this is our time. So if we plug this in, Y equals 7700. Then we've got T is 24 over 20. If we type that in, we should get, let me check, type this in, should be to the nearest whole number, so 3352. Okay. Same thing for 30. We're using, it's depreciating by half. It's going down by half. So the new car is purchased for $50,000. So this is my starting amount. And over time, it multiplies by half every 3 years. This is my H, how long it takes to halve. He wants to know the value T years after it was purchased, like T is 4, so 4 years after it's purchased. What is the value? We want to know the ending amount. So Y equals 50,000 times 1/2 to the 4 over 3. And if we type all that in to the nearest $100, now notice we're rounding to the nearest $100. So let me actually type this one in. 50,000 on the screen equals 1/2. You can put it as a fraction. 1/2. I'm actually do that so I don't confuse you. So 50,000 to the 1/2. Then I have So it wants us to round to the nearest 100. So we're looking at the 8 here. After that is a 4. So we're going to go down to 19,800. So one thing I will say is pay attention to what you are rounding to. Now, on 31, we start to get to our compounding equation. Now, I'm just going to pull this up. And let you write this out, because this would be a lot for my really pitiful little handwriting. So let me find a good image. Obviously, these are not my images. I don't take credit for them. This is a really beautiful one. So it's our ending amount, our principal, P. I would put for P that this is my starting amount. My principal is how much I start with, how much I invest originally. My interest rate is R as a decimal. N is how many times it compounds in a year. So remember, N equals 12 is monthly, N equals 365 is daily, N equals 52 is weekly, N equals 4 is quarterly, that thing, and then T is the time in years that we're using. So go ahead and pause the video and write this on your index card. So we have, let me just write the formula again. I write in caps because my handwriting's bad. Okay. Let me double check my formula here. Yep, looking good. So Luke invested this much, 48,000, into an account with the interest rate of this. So remember, if we move the decimal place twice, we're going to have that R is 0.061, and it compounds quarterly. So that's going to happen. N is going to be 4 times in a year. Assuming no deposits or withdrawals are made, how much money? So we want to know the final amount to the nearest $100 would be in the account after 8 years. So T is 8. Okay, so let's plug that in. So A equals, oh, forgot my 4, 48,000, 1 plus 0.061 over N is 4 to the 4 times T is 8. And we're rounded to the nearest $100, so let me type this in. So we have this right here. We're on to the nearest $100. So this not the 0 after the 9 would make it go to 77,900. 77,900. Okay. 32. Same idea, because we're on this one. It says he invested this much, 10,000. The rate is 0.017. And it's compounded daily, so that happens 365 times in a year. So N is 365. And if you'd like, this is actually a good list you can write out, like on your index card. Annually happens once a year, so N is 1, semi-annually twice a year, quarterly 4, monthly 12, weekly 52, and daily 365. I would pause the video and write that down. So, if I had this here, then what I'm going to write out is A equals, oh, I'm not even done yet. Oops, sorry. Assuming no deposits or withdrawals are made, how much money in the end? So I don't know, my A would be in the account after 7 years. So T is 7. So A equals 10,000. 1 plus 0.017 over 365 to the 365 times 7. And then if I type that in my calculator, we're rounded to the nearest $10. So we're rounded to the nearest $10. So that should give me 11,260. We're rounding right here this time, not tenth. If it said tenth, we'd rounded one decimal place, but it says $10. Okay. And the continuous equation. So important to have as well. Now, just because it's the continuous equation doesn't mean we're always going to have to solve it this way, but it does pop like it does happen to be this time. So David invested $73,000. That's my amount. No, that's my original amount. That's my principal. That's what I'm starting with. Once again, not my formula. I'm just showing you an image on the web here. So the amount, my ending amount is A. P is my principal. E is that mathematical constant, like second ln on my calculator, E. And then my rate is R, and that is T in years. So make sure we write this down. This is the PERT, continuously. If I see continuously, so I'm using this one because I'm using continuous, compounding continuously. That means I've got to use the E equation, okay? So my rate here is going to be 0.016. And we're plugging that into the exponent. So assuming no deposits or withdrawals are made, how long, so we don't know T this time, for the final value, or for the value of the account, so we're doing to the nearest tenth of a year, for the value of the account to reach 9070. So that's my final amount. So let's write it out. So A equals P E to the RT. I like to write caps because my handwriting's bad. So I've got 9070 equals 7300. E to the R is 0.016 times T. Okay, so first thing to do, we're back to like number 17. We've got to get rid of it, use logs or bay, base on bottom, all that good stuff. So let's divide on both sides. It's 9070, right? I figured. So 907 over 730. Oh, I'm all backwards. So let's rewrite this with logs are bay. So B, E, A. So if I rewrite this, I've got log base E of 907 over 730 equals 0.016 T. So I rewrite this with base on bottom. You could just write ln, but a lot of people prefer to do this. Like you could just write ln of this and then divide by this. If you want to, you'll get the same answer. But a lot of people like base on bottom better. That's okay. So log over log of E, then 907 over 730. Then divide by 0.016. So I'm going to type this in first, then divide by 0.016, and we're rounded to the nearest tenth. So let me show that. showing it this way. Okay. Then we divide by 0.016. So approximately 13.6. So it's going to take about 13.6 years. The nearest 10th figure. Then on 34, it says Nathaniel invested this and we're compounded daily, so we're using the other equation this time. So this is my P, this is my R is. No deposits or withdrawals are made. How long would it take? We don't know our time. For the value of the account to reach this. So our final amount is this. So we're using this equation this time. Sorry about that. Then I'm going to have 900, 37,001 plus 0.057 over compounded daily. I forgot to write this out here. Would be n equals 365. How many times does it happen in a year? So 365. And we don't know t, so 365 t. And then I'm going to divide on both sides by this. Oh, too many zeros. Just making sure. Yep. I would just leave this like this for now. I would, because this is going to give you a really ugly decimal. So I would not actually combine this guy. I would just leave it like this. It's going to look ugly, but that's okay. Now I'm going to use logs are bay. It's my base. This is my exponent. This is my answer. So log base all of this. I'm just writing this parentheses because it's one big thing. Log base this of my answer, BA, equals 365t. So let's rewrite this with base on bottom. My wrist is starting to cramp up a little bit from not with the mouse so much. So I'm going to type all this in, then divide by 365. Okay. So let me shove this over here. type that first part in. And then, like I said, I need to divide by 365. So approximately, we're rounded to the nearest year, so that would be 11. So t is about 11. Okay. And something that's actually going to be really nice for you, we're almost done because I printed 2 extra. So leave off 37 and 38. We're not going to do those. We're just doing 35 and 36. So your test is going to be a 20-question test selected from some of these. So let me mark this out. So Arun is going to invest in an account, pay an interest. So this is my rate. Compounded daily, so N is 365. How much would Arun need to invest to the nearest $100? How much would he need to invest? So that means we don't know P this time. For the value to reach this, for my final amount to be this in 5 years, when T is this. So we don't know P this time. So 1 plus R is 0.024 over N. Oh, my N is 365. 365 times 5. So the nice thing about when I find a P, this is just saying P times everything in parentheses with the exponent, right? So I'm going to divide by this on both sides. Divide by the parentheses on both sides. I'm going to divide by this on both sides. So what do I mean? Well, I just didn't want to write that out because I'm lazy, but let me write it out as a fraction for you. So I'm dividing 78,000 by this whole parenthesis expression. So 1 plus 0.024 over 365 to the 365 times 5. So I'm just putting my full expression in here, okay? Like exponent and all. So 78,000 on top, this on bottom. So, and we're rounding to the nearest $100. So 69,200 is what this would round to. 69,200. 69,200. So the P would equal, so P equals 69,200 approximately. Okay, same thing for this one, except for it's compounded continuously. So I've got to use the E equation. My rate is this. It's actually a little easier to type in. It's the nearest $10. How much would they need to invest? We don't know P. For the final amount to be this in 7 years. So my T is 7. So A equals P E to the RT. I want my final amount to be 72,000. I don't know my principal, my P, so I've got E to the 0.02 times 7. So I'm going to divide by this on both sides. You can put both these in parentheses if you'd like. So the principal would be, round to the nearest $10, should be $62,590 approximately.